This video is to run through how to do the forecast of GDP using an autoregressive method, and then we're going to incorporate that forecast into a quadratic model with GDP. And we're going to use as much as possible what we forecast from a GDP standpoint. So under GDP, we're using autoregressive methodology. I'll go ahead and delete my existing forecast. Our first step is what we're saying is that the GDP for 1993 predicts the GDP for 1994, which then predicts the GDP for 1995, etc. So what we want to do is simply grab our GDP numbers, copy them, and then paste them down. So this would be the GDP for 1993, and it's going to be used as a regressor for the GDP in 1994. Our next step is to go ahead and estimate our regression. So in this case, we're going to highlight over 2 and then down a few, since we have 2 variables here. And it's equal to linest. Our known y's are going to be the actual GDPs. Our known x's are going to be the lagged GDPs. Notice we're lining these two guys up. Comma 1, end it with a parenthesis, and then Control-Shift-Enter. And that's going to generate our estimate. This would be our coefficient. This is our intercept. And then our forecast is simply going to be equal to our intercept. We'll hit F4 to lock that in, plus our coefficient. We hit F4 to lock that in, multiplied by the lag GDP level. So this is the forecast value, and we'll just go ahead and drag that down. We can go up through 2013 for our projections. If we wanted to go to 2014, then we'd actually have to put our forecast value for 2014 in here as the lag value. So we're forecasting 2013, and then we apply our equation again. We're not going to do that for this one. Next thing we'll do is come to our quadratic equation with our GDP. We have our x's that we've stepped down through, starting with 0, going up. We have our x squares, which is just the x, and we caret 2 to get the square of the function. And then for our 1993 GDP, it's just going to be what it was. Our formula doesn't work for the first period. If we could download previous data for like 1992, then we can get it to work. But as a first approximation, you'll have to do this a lot of times in your regressions. So it's a good approximation. We're just going to use the 2.7. And then after that, we want to use our forecast GDP. So we would just set this equal to our actual forecast value, and then go ahead and drag this equation down. I'll just do it through 2012 in this case. Now it comes to the estimation. We want to estimate what our equation is. In this case, pretty straightforward. Again, we want to equal linest. And our known y's are our actual sales data. And our known x's now are going to be our x squared, and our GDP. Just do that for 2011 so that they're balanced. Comma 1, end it with a parenthesis, Control-Shift-Enter, and that's going to generate our forecast. We have here the GDP coefficient, and then it's going to be x squared coefficient, and then just x, and then an intercept. So we apply that equation. If I double click up here, we'll see our intercept is F31, and then we're going to add that to, we have green here, so that's going to be our x function, and then we'll multiply that by B4 plus D31, which is our x squared, and we'll multiply that by our square function plus C31 right here, and we're going to multiply that by our GDP. And that's our error. Our error function is just going to be the actual minus the forecast, so that's our error. All of our plots have gone ahead and updated. We have our fit of our plot using the quadratic formula, and we have our error terms here. We can see our error is kind of up, then it's kind of consistently down, then it's consistently up, and then we tail off. So this is kind of a signal of a model that's not quite fitting really the way it should. We need to do a little bit better. So in order to do better on this particular equation, this particular fit, we're going to do two things. One of them is going to be to go ahead and add our dummy variables in to try and control our errors a little bit better. So this is with two running dummy variables that allow for two separate intercepts. So there's one intercept for here, and then there's one intercept for up here, starting in the last 4 years. So here's one and here's one. And then we're just using our regular x variable as a linear regression. And you'll have to play around with it to see what happens. And this, I'm also using the log transformation of sales data to try and take the curve out of it as much as possible. And here we've done a lot better with our error terms. We're definitely underperforming here, we're overperforming here consistently, but it's become a lot more random compared to, say, our linear estimation where we're over or down, we're up or down. So what we're looking for is something that kind of bounces around the 0 point, and in terms of our second dummy variable, that's pretty close. Alright, so I'm going to create a separate video for how to use the dummies in terms of the natural log. I think I've gone over enough so that you can generate your own quadratic estimation. Obviously your quadratic with the GDP, and then our log transformation. Thank you very much. Goodbye.